Welcome to another of Mythology's video. This video is part of the number system series, and we're going to be covering factors and prime factors. A prime number is a number that only has two factors, which is one in itself. For example, the number 3 is a prime number because 3 only has two factors, which is 1 and 3, meaning that only those two numbers can be divided into it. There are many techniques to finding prime factors, but in this video, we're going to be using the repeated division method, which is when you keep dividing a number by a prime until you reach 1 and you can't divide it any further. So, for example, if I have the number 18 and want to find the prime factors of it, I would start off by looking at which of the prime numbers can be divided into 18. Because 18 is an even number, we know that 2 can be divided into 18. This results in 9. And because 2 can no longer be divided into 9, we move on to the next prime number, which is 3. And we find that 3 indeed can be divided into 9, resulting in 3. And because we know that 3 is a prime number, the only other possible prime number left that can be divided into 3 is 3, resulting in 1. And remember, when you reach 1, you know that it is the end of your prime factorization. So after you've finished finding the prime factors, these circled numbers on the sides are all the prime numbers that are multiplied together to get 18. We can write down the product of its prime factors by multiplying all these numbers on the sides together. In this case, for 18, it is 2 times 3 times 3. And the prime factors of 18 are 2 and 3. The tricks to prime factor finding is to start off with the smallest prime numbers and see if it can divide into the number. If it doesn't, then you continue on to the next prime number. Usually in an IGCSE exam, prime numbers never typically exceed 29, so I definitely recommend that you memorize prime numbers up to 29, because this would definitely help speed up your calculations. To make sure that you really understand prime factorization, here's another example. 294. So we would start off with the smallest prime number, which is 2. 2 can be divided into 294, resulting in 147. But 2 can no longer be divided into 147. So we move on to the next prime number, which is 3. 3 can be divided into 147, giving us 49. And 3 can't be divided into 49. So we move on to 5, which is the next prime number. 5 also can't be divided into 49, so we move on to the next prime number, which is 7. 7 can be divided into 49, resulting in 7. And because 7 is a prime number, the only prime number that can be divided into it is itself. 7 divided by 7 is 1. So we know that that's the end of our prime factorization. So all the circled numbers on the sides are the prime factors of 294. So we write the product of its prime factors by those circled numbers multiplied together. And the prime factors of 294 include 2, 3, and 7. Now for finding factors of a number, this can be found similarly like finding prime factors, but instead we're also going to be working out all the possible combinations. Here, we start off by 42, and again, using the same approach, we start off with the smallest prime, and we divide 2 into the number. We then get 21. 2 can no longer be divided into it, so we move on and divide 21 by 3. Remaining is 7, so we divide that by 7 to get 1. And now, when we reach 1, we know that we've finished with our prime factorization. Take all the numbers on the left side, or the circled numbers, and work out all the combinations like this. Firstly, each of the numbers shown here are all factors of 42, because they can all be divided into it. We start off by circling 1, because it is one of the factors of 42. And then we move on to the next number, which is 2. One of the factors of 42 is 2, so we write that down. We then find all the possible combinations that this 2 can match up with, which is firstly 3. 2 times 3 is 6. Another possible combination with this 2 is 2 times 3 times 7, which is 42. We then move on to 3. 3 is one of the factors of 42, so we write that down. 3 can also be paired up with 7. 3 times 7 is 21. The next possible factor is 7, so we include that. And then lastly, the other possible combination left is 2 times 7, 14. So all of the highlighted numbers here is the answer to all the factors of 42. The factors of 42 include 1, 2, 3, 6, 14, 21, and 42.
Thank you so much for watching, guys, and make sure to give this video a thumbs up and subscribe to our channel for more upcoming math contents.